Good evening and welcome to TL Physics. My name is Sarah and today I'm going to talk about using displacement time graphs to be able to get velocity time graphs and then the acceleration time graphs from it. So here I have a displacement time graph, and I'm using the word displacement because that is the vector involved with distance. So distance is a scalar, which means it hasn't got a direction but it has a magnitude. So an example is if I go 2 steps this way and 2 steps back, in total the distance I have travelled is 4 meters. But my displacement, my distance from my original position, is 0. And that is important because displacement has a direction as well as a distance. And on this graph here I have a positive and a negative, which means that when I go into a velocity time graph or into an acceleration time graph, I can go into the negative region for that. So this is my displacement time graph, and velocity time graphs are related to displacement time graphs because these are the gradient. There's a graph to show the gradient of the displacement time graph. Okay, so here I've got a very strange graph. I've put it quite strange. I've put a quite curved graph just to show you what's going on. Okay, in a previous video I would have done some basic stuff looking at graphs and how to analyse them, but today I'm actually speaking about how you can draw graphs from other ones. So this is my gradient, and as you can see my gradient starts off quite steep and goes to the point where it hasn't got any gradient at all, and that's at 10 seconds. So my gradient starts off positively quite big and then goes all the way to this gradient where it goes quite shallow. Okay, then it gets negative and then it goes all the way and it gets to the point where it's really quite negative here, and then it starts getting shallower until about 20 when it goes back to 0 again. So I'm going to draw it on here. So I start off with quite at time 0, quite a steep gradient. And as it gets to 10 seconds, that gradient gets shallower and shallower and shallower. Okay. Then at this point here, my gradient is negative. It's a negative gradient, but it's not very big. And then it gets bigger and bigger and bigger and bigger. Okay. And then it gets lower and lower and lower and lower, but it's getting less and less. So it's going to happen here. So let's say the steepest point should be around here. Let's say this is at 15 seconds here. So what's going to happen? It's going to get bigger. It's getting more and more and more and more and more negative. And then all of a sudden, about 15 seconds, it will change here to being less and less negative until it gets to 20 when it's about 0 again. Okay. So again, gradient starting really positive, getting less positive to no gradient, then being a little bit negative until it's really negative, and then becoming less negative until it's 0 again. So as you can see here, I've got this lovely graph showing my gradient here. And this is important because you can see the velocity has gone into the negative region. Now, much like the velocity time graph is the gradient of the displacement time graph, the acceleration time graph is the gradient of the velocity time graph. So this is the gradient of the velocity time graph. Okay, so that's what I'm going to do. My gradient at here is 0. So I'll start at 0. At 10 seconds, my gradient is extraordinarily negative. In fact, it's probably the most negative it will be. Okay. At 15 seconds here, it's 0 again. So I've put the 15 in. And at the 20 here, I've got the most positive it could be up here. So I end up with a graph that looks like that, which kind of makes sense if you think about it. What's happening here is that my velocity to start with is quite big, but for some reason I'm slowing down. So my velocity is really high, but then my amount of distance I'm travelling is getting less and less and less. and I'm slowing down, which means that my acceleration or deceleration, because it's negative, is getting much, much bigger. So when I'm at my most slowing down, when my velocity is the least, here, 0, I have the most deceleration. When my velocity again here is this 0, I must have accelerated quite a bit to try and get it back up to 0 because I've gone really negative. Okay? So that there is how you get from a displacement time graph to a velocity time graph to an acceleration time graph. In a previous video, I went over how to get calculations and data from this. This is just a graphical representation. And this is going to be really important later on when we're doing things like simple harmonic motion, and you need to be able to just look at the displacement, velocity, and acceleration for a swinging oscillator or a pendulum.